Here is part 2 of the solving three variable systems videos. So I'm going to go ahead and start solving this next one. I'm going to do numbers 3 and 4 in this video of that document there. So I have x minus 3 plus 3 equals -6, and then I'm looking at the second equation. I don't have any easy eliminations just from the very start here. Looking at the third equation, x, I have 1, -2, 3, 3, 6, 9, 3, 6, nothing. That's going to eliminate easily. So I have to generate a advantageous scenario here where I can eliminate something. So what I'm going to do is I'm going to multiply the top one by 2. So I'm going to multiply equation 1 by 2. And the reason I'm thinking about that is because I want to make this x a 2. That's what I want to have happen. So I have to multiply the whole top equation by 2. So let's go ahead and do that. So 2 times x, 2 times -3, 2 times 3, 2 times -6. So 2x minus 6y plus 6z equals -12. And I'm going to use equation 2, so -2x plus 6y minus 6z equals 12. Now what I've generated is a scenario where I have 2 and -2. So I'm going to add my columns together. 2 plus -2 is 0. -6 plus 6 is 0. 6 plus -6, 0. -12 plus 12, 0. I get 0 equal to 0. So in this problem, the x, the y, the z, they all dropped out, and we get a statement saying 0 equals 0. 0 does in fact equal 0, so we would say infinite solutions, because we get a true statement. So that means there's infinite solutions. So that could translate to, if you're looking at the, let me go to my 3D plane here. I didn't grab any pictures of that, but all it would look like, it would just look like the same plane. It could be just the three planes stacked on top of one another. Maybe I shouldn't use red on red. Just the 3 planes stacked on top of one another, because they're the same equation. So it would just be these 3 planes just completely stacked on one another, and there's infinite solutions there. So that's number 3, infinite solutions. And I'm done. I don't even have to continue. Like, I know in the other video problems, we had to, go through this whole process of finding an x, y, z, but those were one solution where we had a single point where all 3 planes cross paths. But here, I just end up happening to get 0 equal to 0, so that's infinite solutions because it's a true statement. So get number 4. In this one, I have one of the equations missing an x, but that's not a big deal. I'm noticing right away that I have this 4x and 4x. So I'm just going to start there. That's my, I see same variable, so I don't know what's going to happen. But let's just go. Let's just go with it. So I'm going to take equation 1, 4x minus 3y plus z equals -11. And I'm going to take equation 3, 4x plus 3y plus 2z equals 15. Equation 3. Now I'm going to subtract because I have 4x, so I'm going to subtract these. And when I'm subtracting, 4x minus 4x is 0, so I've eliminated the x's. -3y minus 3y is -6y. 1 minus 2, so 1z minus 2z, so 1 minus 2 is -1, so -1z equals -11 minus 15 is -26. Look what happens. I've created an equation of y and z, a 2-variable equation. Look at equation 2. That's also a 2-variable equation. So I don't have to generate a whole new equation because I already have a 2-variable equation in the same 2 variables, y and z. So now I'm going to take just equation 2, 6y plus z equals 24. And I'm going to solve the 2-variable system now. I have the same -6 and 6 opposite coefficients, same thing with the z. So I'm going to add -6 plus 6 is 0. -1 plus 1 is 0. -26 plus 24 is -2. So I get 0 equals -2. That's a false statement. 0 does not equal -2, so in this case, we get no solution. No solution there, because we get a false statement. And the other one, where we had infinite solutions, you get the exact same number. It's like 5 equals 5 or 0 equals 0. That's equivalent. There's the same thing, so that means that there's infinite values. But here we get false statement, so there's no solution. What that would look like visually on a plane here is you just have 3 planes just parallel to one another. So it's kind of hard to draw, but it would just be like, here's a plane right here, and just never crossing. Then another one over here somewhere, but they'd never cross. It'd just be 3 planes parallel to one another, just like how in a no solution 2 variable system, you just have 2 parallel lines. You'd have 3 parallel planes. It's actually not that bad. That's not a bad drawing. Not terrible. So here it is. So no solution. Yeah, so that's why I wanted to break this up into 2 parts, because I wanted this one to just to be strictly the non-one solution scenarios. So that was an infinite and a no solution.